Hello everyone, welcome back to my channel. If you like the videos, please do like, share and subscribe so I know to make more. Today we are going to talk a little bit about binary trees, and next week we'll continue that. So today it's just going to be a quick summary about them, because they're unlike arrays or linked lists or stacks and queues, what we've done before. So they're linear data structures, which are linear data structures. Trees are hierarchical, so they're like a tree. So tree vocabulary then, the topmost node is called the root of the tree, and so the elements then stem from that. So the elements that are directly under each element are called the children. So you've got the node and the children, and the element directly above something is called the parent. So we've got a parent-child relationship, and for example, the trees then, they also have elements with no children are called leaves. So we definitely adopt all of the tree language when we talk about binary trees. So we have our root is our top node, then we have our parent and our children, and parents with no children have leaves. So elements with no children have leaves, so parents with no children have no leaves. So why trees then? Trees are one of the most important for storing because it naturally forms a hierarchy. Trees like binary trees, binary search trees provide moderate, like quick access and things like that. We've got insertion and deletion, and like linked lists and unlike arrays, trees don't have an upper limit on the number of nodes, as nodes are linked using pointers, and pointers are really important for other languages as well, like C++, if you're using pointers, because you have to point to a particular part of the memory, and then you also have to free the memory, but that's another language, so we don't have to worry about too much about that. Java has automatic garbage collection, thankfully. So the main applications of trees then are that it's a hierarchical data. We can manipulate the hierarchical data. We can sort the data list. We can also have digital images as views as well. We have router algorithms, and then with a binary tree, a tree whose element have at least two children is called a binary tree. So we have our node and then our tree, and that's our binary tree. So with all of the trees and data structures like that, there's obviously the tree is the hierarchical data structure. We have moderate access and insertion and deletion to the trees, and the properties then of a binary tree. So we have our root or our parent, and then we have our two children, which is really important to remember. So we adopt all of the tree language as we go along. With linked lists, we had our lists like this, so they're in a different structure. With the tree, it's hierarchical. We have to always remember this so that we can access it better. There's also different types of binary trees as well, but for example, with the properties, then the maximum nodes at level L of a binary tree is 2 to the power of L. The maximum number of nodes in a binary tree of height H is 2 to the power of H minus 1. So here the height of the tree is the maximum number of nodes on the root to leaf path. So root to leaf path. So when we talk about trees as well, we have paths, nodes, parents, children, and leaves. So far so good with the vocabulary. In a binary tree with n nodes, minimum possible height or the minimum number of levels is log to the base 2 n plus 1. So this can be directly derived from point 2 above, and then a binary tree with L leaves has at least log 2 L plus 1 levels. So if you're unsure about anything to do with binary tree vocabulary, that was pretty much the summary of binary trees. For the vocabulary, next week we will do the actual program itself in more detail, and we'll step through it because there's a little bit more to cover with this data structure. With binary trees, the main things again to rehash over it. You've got your node is your root, your nodes, parents, children, parents with no children are leaves, and obviously with the binary tree structure then it's going to be a little bit more trickier to implement compared to a lot of the other types. And then there's also different types of binary trees as well. So we have heap and hash. That's why I said rehash over it. So the types of binary trees as well, which we'll go through next week. Okay, thanks for watching. Have a beautiful Sunday, and please like, share, and subscribe if you like these videos, if you want me to make more. And yeah, we've got a little bit more to cover with binary search tree, binary heap, and hashing as well next week. So thanks for watching. Bye.